Out in the silent darkness of space, there are places where creation and destruction are locked in a violent, eternal dance. Places where new suns are forged in fire, while the ghosts of dead ones scatter like ash. These aren't the serene celestial clouds you might imagine. They're cosmic battlegrounds. And what if I told you that the very elements in your body were forged in these chaotic wars, billions of years ago? When you see a breathtaking image from the James Webb or Hubble telescopes, you're likely looking at a nebula. We see them as beautiful, ethereal clouds of gas and dust painted across the void, but that placid beauty is an illusion. These structures are some of the most dynamic and violent environments in the universe. Some are called star nurseries, and for good reason, they are the birthplaces of stars. But they are also stellar graveyards, the remnants of suns that have lived and died. A nebula is a distinct, luminous part of the interstellar medium, made up of gas like hydrogen and helium, along with cosmic dust. Understanding them means understanding the fundamental cycle of the cosmos, a universe that is constantly recycling itself, turning death into life on an unimaginable scale. They're where the story of stars, planets, and even us, begins and ends. The cradles of creation deep within a galaxy's sprawling spiral arms, you'll find enormous clouds of cold gas and dust, sometimes stretching for hundreds of light years. These are molecular clouds, the raw material for creation. For millions of years, they can just drift. But the universe is a chaotic place. A shockwave from a distant supernova, or the gravitational tug of a passing star, can send a ripple through the cloud, disturbing its delicate balance. That's the trigger. Gravity, the architect of the cosmos, gets to work. It slowly pulls together clumps of gas and dust. As these clumps get bigger, their own gravitational pull gets stronger, sucking in more and more material in a runaway feedback loop. The cloud starts to collapse inward, breaking apart into several dense cores. At the center of each core, the material gets so tightly packed that the pressure and temperature skyrocket. This hot, dense, embryonic star is called a protostar. It's not a true star just yet, it's on the verge of ignition, still wrapped in the dusty cocoon of its parent cloud. When the core temperature hits a staggering 10 million degrees Celsius, something incredible happens: nuclear fusion ignites. Hydrogen atoms start fusing into helium, releasing a tremendous amount of energy. This outward push of energy finally balances the inward crush of gravity, and a stable, new star is born. It emerges from its dusty veil, shining for the very first time. These stellar nurseries are often a type of nebula known as an emission nebula. They glow with vibrant colors because the intense ultraviolet radiation from the hot, young stars they've just created energizes the surrounding gas, causing it to shine. The most common element, hydrogen, glows with a distinct reddish hue, giving these regions their signature look. Perhaps the most famous star-forming region is the Orion Nebula, a vast stellar nursery located about 1,350 light-years away. It's the closest massive star-forming region to Earth, and it's so bright you can even spot it with the naked eye as a fuzzy patch in Orion's sword. At its heart lies a group of brilliant young stars called the Trapezium Cluster, whose fierce radiation is carving out a huge cavern within the nebula and lighting it up for us to see. Equally iconic is the Eagle Nebula, home to the awe-inspiring pillars of creation. These colossal towers of cool gas and dust are several light-years tall. They might look solid and permanent, but they're fragile columns being eroded by powerful winds and searing ultraviolet light from a cluster of young, massive stars just out of frame. Within these dense pillars, new stars are still being born, hidden inside small knots of gas that are collapsing under their own gravity. The James Webb Telescope has given us an even more detailed view, revealing newborn stars as bright red orbs and showing jets of material blasting out from these infant suns. These aren't peaceful landscapes, they're active construction zones where the universe is building its next generation of stars. Echoes of light and shadow. Not all nebulae are raging furnaces of star birth. Some are more subtle, playing a game of light and shadow in the space between stars. These come in two main types: reflection nebulae and dark nebulae. A reflection nebula shines not because its gas is superheated, but simply because it's reflecting the light of a nearby star. These nebulae are full of fine dust grains that don't get hot enough to glow on their own. Instead, they act like cosmic fog lit up by a distant street lamp. They often appear blue for the same reason our sky is blue: the dust particles scatter blue light more efficiently than red light. A perfect example is the haze surrounding the Pleiades star cluster, where light from the brilliant Seven Sisters illuminates a passing cloud of interstellar dust. Then there are the dark nebulae. These aren't empty patches in the sky, but clouds of gas and dust so dense they completely block the light from whatever is behind them. They're visible only as silhouettes against a background of distant stars or brighter nebulae. One of the most famous is the Horsehead Nebula, a dark, swirling pillar of dust that stands out against the glowing red emission nebula behind it. These dark clouds aren't empty voids, they are often the coldest, densest parts of a molecular cloud. Some of the smallest, most isolated of these are called Bok globules. And it's within this cold darkness that the seeds of future stars lie dormant, just waiting for gravity to kick off the process of collapse. In a way, these dark nebulae are the quiet before the creative storm. The universe is constantly revealing more of its secrets, from the birth of stars in these nurseries to the discovery of life's building blocks in space. To make sure you don't miss the next chapter in this cosmic story, subscribe to our channel and hit the notification bell. You'll be the first to know when we explore the next amazing phenomenon. The cosmic ghosts: for every star that is born, another will eventually die. A star's life is a constant battle between the outward pressure of nuclear fusion and the inward pull of its own gravity. When a star runs out of fuel, gravity wins. What happens next depends on the star's mass, and it creates some of the most hauntingly beautiful objects in the cosmos: planetary nebulae and supernova remnants. These are the cosmic ghosts. For stars like our own Sun, the end is relatively gentle. When a Sun-like star uses up the hydrogen in its core, it swells into a red giant. The core keeps fusing helium into carbon, but eventually, that fuel runs out, too. The star becomes unstable, pulsating and casting off its outer layers into space. These expelled layers of gas drift outwards, forming a beautiful, expanding shell. This glowing shroud of gas is called a planetary nebula, a confusing name, since it has nothing to do with planets. At the center remains the hot, dense core of the former star, now a white dwarf, which lights up the gas it just shed, causing it to glow. One of the closest and most spectacular planetary nebulae is the Helix Nebula, located about 700 light-years away. Often called the Eye of God, it gives us a stunning preview of our own Sun's eventual fate. Recent images have revealed its incredible complexity, showing how a dying star recycles its material back into the cosmos, seeding space with the elements for future generations of stars and planets. But for stars much more massive than our Sun, the end is anything but gentle. These giants burn through their fuel much faster, living short, brilliant lives. When they run out of fuel, their massive cores collapse in a fraction of a second, triggering a titanic explosion known as a supernova. This event is so powerful it can briefly outshine an entire galaxy, blasting the star's outer layers into space and scattering all the heavy elements forged in its core: carbon, oxygen, iron, all the ingredients necessary for planets and life. What's left behind is a supernova remnant, an expanding, turbulent cloud of debris. The famous Crab Nebula is the ghostly aftermath of a star that was seen to explode by Chinese astronomers in the year 1054. At its center is a pulsar, a rapidly spinning neutron star, the crushed remnant of the massive star's core. These remnants are the ultimate act of cosmic recycling. They enrich the galaxy with heavy elements and send out powerful shockwaves that can trigger the collapse of nearby molecular clouds, starting the cycle of star birth all over again. From the fiery furnaces of the Orion Nebula to the ghostly glow of the Helix, nebulae are so much more than just pretty pictures. They are the engines of cosmic evolution. They're where gravity wages war on gas and dust to forge new stars, and they are the beautiful memorials left behind by stars at the end of their lives. These cosmic ghosts and stellar nurseries are locked in a grand, perpetual cycle. The matter from dying stars is returned to space, enriching the void with the building blocks of everything we know. This material then collects in new nebulae, waiting to be drawn together by gravity to form the next generation of suns, planets, and perhaps, life. The very iron in your blood and the calcium in your bones were forged in the heart of a massive star that exploded billions of years ago. You are, in the most literal sense, made of stardust, recycled through these very cosmic ghosts.